I'm curious, Paradigm Engineering Solutions, you and I have spoken a million times casually at different events we've been at or just kind of in passing, but I've never really sat down to find out what is Paradigm. But in particular, I love the second sentence there, intelligent solutions or structures. What does an intelligent structure mean? So tell us a little bit about Paradigm and what is the intelligence?
Okay. So Paradigm Structural Engineers was founded in 1999.
Okay.
I had worked for another company for about 10 years and a whole bunch of companies before that, trying to kind of find my place. Always wanted to be a consultant. Always thought that I could provide the most information to my prospective clients if I understood a lot of different technologies relative to structural engineering. So that's kind of why I started the company, focused mainly on, as the byline goes, intelligent structural solutions, because I tend to try to look beyond what minimum code might be for designs, and I try to encourage that of my staff to do the same thing. So, we typically hire the really smartest guys that we can and ladies that we can find. A lot of very intelligent people work at my company, and I'm really excited about it. I'm always shocked by how smart they are, which is fantastic. But the byline of intelligent structural solutions really focuses on what's the best solution for a particular challenge for a client. So if it's an existing building, is retrofitting the building the right solution? Is incorporating passive energy dissipation like shock absorbers into your building the right solution? Is base isolation the right solution? Or is heavy duty adding concrete shear walls the right solution? Or increasing the braced frames quantity? Is that the right solution? Is stiffening the moment frame the right solution? A whole different type of things. A lot of times what happens is when buildings are looked at or even designed, they're designed to the requirements of a building code, which is a good baseline. Our belief is that from a standpoint of protection of either people or content, you need to be beyond minimum code. You really should be. The code addresses that. It allows, minimum code provides for safe exiting from a building by all personnel. So a hospital, you design to a little bit higher standard, roughly 50% higher standard. A data center, we do that frequently. Sometimes we go beyond that. Unfortunately or unfortunately, data centers, the value of the content inside that data center, I don't want to, try to value someone's life, but when you're talking billions of dollars of content inside of a building, many would say protect that content. Be very careful.
I could see, in the, in these other infrastructures, like absolutely, we got to protect the kids, we got to protect the, mental health patients, and we got to get the physically impaired or what are all these other folks. Data center people, are they really that valuable?
Well, so that's the funny rub is it's not necessarily the people in the data center.
Right.
It's the servers.
Yeah.
Or if it's a biopharma lab, it's the product that's being manufactured because, the raw content in and of itself is not overly valuable. But once you create the drug or create the pill, there's value.
Or even if it was like a bacteria or something you're trying to protect, like, I don't want that to get, if I'm the CDC, which is right down the street, they got stuff in there that we want to make sure no matter what the event is, it stays where it's supposed to be and doesn't accidentally get released.
Exactly. Yeah. And we do a lot of, biosafety lab type buildings, BSL-3, BSL-4 type stuff for just that reason. So we tend to enjoy, if you will, looking at very technical problems. If it's a cookbook solution, after 2 or 3 of those cookbook solutions applied to a given building, we have a tendency to say, you know what, there are other people that you can hire to do that. We'd prefer to take on a new challenge. And whether that's smart or not smart, sometimes I'm not sure, but at the same time, it always is challenging to our employees.
Yeah.
And we're always helping push the industry forward. And as an example, we were fortunate enough to design one of the first base isolated buildings in data centers in Northern California. And base isolation, I'll just quickly tell you what it is to make it simple.
I'm curious because you referred to base isolation or shock absorption, whatever. I've seen base isolation pads within a cage.
Yeah.
But why such an emphasis? I presume in a seismic area like California for sure, but people are talking about this across the United States, not just the West Coast. Why the emphasis?
Well,
So what is it and why the emphasis, I guess?
let's start with why the emphasis or emphasis. So California is obviously well known for seismic activity. The Salt Lake City region, quite well known for that. The Yellowstone National Park, very well known for that. Not a whole lot of building going on up there. But then as you come across the country, you get to the New Madrid Fault, which is in southeastern Missouri, northeastern Arkansas, and western Tennessee. A very, very high concentration of very large seismic activity potential on that New Madrid Fault. Additionally, oddly enough, there is some seismic activity in central Virginia, kind of right in the middle, as well as over actually central and kind of eastern Tennessee. And then the Charleston, South Carolina has a potential. So now the question is, why the focus? When the United States Geological Survey identifies seismic hazard, you look at it from a standpoint of what is the probability of the earthquake being larger than a given event. So often a given event is, roughly we use magnitude to talk to the public, but generally magnitude translates loosely to some type of ground motion. So one of the largest earthquakes in the United States actually happened on the New Madrid Fault, where buildings as far away as Minneapolis felt the shake and were damaged as back in about 1830s, 1840s, something like that. Anyway, so base isolation, why is there a focus on that? So there are manufacturers out there that will isolate either actual equipment or servers. Those are called ISO bases, where the ground motion occurs, and then instead of those accelerations that occur at the ground being transmitted directly into the server cabinet, that ISO base is successful at diminishing the accelerations by letting the cabinet move. So the cabinet and therefore the equipment doesn't absorb the energy by the ground motion. Transfer that now to a complete data hall. So there's a thing called an ISO floor, which you basically isolate the entire floor. That's another solution. All those are great. However, from a standpoint of protecting all of the operation of the data hall and the entire data center, I believe, and many of us believe, that if you can protect and ensure that you essentially have this island that will be protected against ground motion, your data center will continue to operate with little to no damage. You may have to, pick your cabinet or pick your computer up off the countertop. That doesn't really happen much anymore. Most everybody has laptops anyway.
Right.
So, but the idea is you essentially build your building on an slightly elevated floor, and that elevated floor has either rollers or bearings or lead rubber filled isolators underneath that first floor. And when we do it, we put everything on that. We call it the isolation plane. We put the generators on there. We recommend we put all of any storage water, everything on that isolation plane, so that the only possibility of downtime would be occur from incoming utility loss. So you put flex joints and all that kind of stuff, hoping that you can ensure that the all of the incoming fiber certainly is protected. Incoming and outgoing water and waste materials, you put in flex joints for that are pretty robust, and they can take a lot of displacement. But ultimately, you want the data center to continue to operate and do its job. So the putting it on that isolation plane, again, helps to protect the building and therefore its contents from being damaged. So that's why we like base isolation. So.
How do people process? Because it seems like it is more complicated. I'm introducing more joints to maintain. I'm introducing more bushings to maintain. How do you have that conversation? I guess what I'm trying to say is, what's the balance between, I have a truck outside, a big F250, but I don't have two 5-gallon spare tanks on it because I'm not crossing the Serengeti.
Right.
I'm just driving up the road to the lake. So what's the right mix of evaluating, you need this level of redundancy and complexity at a risk that the risk may not be apparent to everybody?
Yeah, great question. So how we try to counsel our clients is that if this is your only facility, let's say it's you have the entire facility for yourself, for your own use, and you don't have any other data center. I would encourage, in a seismic area, I would encourage the client to consider it, because they are not shedding any of that information out to another data center. You know, there are clients in the world that have multiple data centers that carry the exact same information. And if one data center were to go down, they've got the backup somewhere else in Omaha, let's just say.
Right.
I'd be hard-pressed to suggest that you base isolate your building for the redundancy of that. That doesn't make a lot of sense to me. Now, those are the same clients that can afford $1 billion loss on of a bunch of servers, because they own it all and they own the information that's on there, as opposed to somebody that might only need, say half a dozen cabinets. They may say, or even a dozen cabinets, basically one cage if it's in a colo environment. They might say, well, how do we protect that one cage? And it's like, well, that's where you might want to consider going to, as I mentioned, either an ISO base to the cabinets or an ISO floor, or go to a building that is base isolated, which the tenant that we had, or the client that we had, that's exactly how they market that building to their tenants. They happen to have a completely full cycle now. So, I mean, everybody's in there.
Right.
So good for them.
Right.
Now, we've done another project in another part of California where it was a financial client that it was their only data center, and the amount of income that they make by minute is astonishing. The client clearly understood the benefit of protecting his servers,
Right.
and therefore it was an interview, but he had read all the papers I had written about passive energy dissipation and all, and it was he basically said, tell me how to implement this in my building.
Right.
And so it was a lot of fun,
Right.
very enjoyable. So, and what our job really is that, just like, no single building is the right solution for every
Iteration.
every iteration. Yeah. I mean, if you're in Northern Virginia, maybe a precast building makes sense because you can get it quickly. There's no size or very low seismicity. The winds aren't that bad. You can do what you want. We're doing a bunch of them. You've done a bunch of precast buildings in the area. But as you get out of a region that has precast plants, sometimes it gets a little less attractive. So you go to a steel building. Sometimes procuring steel is challenging. So even though you might be in an environment which generally one would think would be best to go with a steel building, because of being able to acquire the materials fast enough, sometimes precast is can be faster, and vice versa. So you kind of have to look at those a lot, And then there's the concern of, are we doing the right things for the environment? One large company recently did a incorporated mass timber into their data center, and so there are pros to that in that you don't have to use the metal deck, so you have this mass timber that is either the form for your diaphragm or you're going to put concrete over your mass timber. The problem with it is because you don't want to have a lot of columns, you either have to have more columns, because if you're using wood mass timber girders to support the mass timber floor, or you use steel to span further, but then when you use that steel, it can't really be composite with the mass timber. So you have to kind of weigh am I really helping, or am I just am I just making a something better from the standpoint of I'm using a renewable resource rather than a non-renewable resource in the metal deck, let's just say. So there's a variety of things you can do. We always encourage our clients that if you really want to focus in on incorporating a smaller carbon footprint, possibly focus in on using mass timber in your office space as opposed to in the data hall. And there's a lot of varying opinions about that, but that's our opinion.
Yeah. I don't know if I'm getting this right, but as I'm imagining an entire data center in the way that you describe it, for some reason, like one of those hula girls come to mind. Like it can do the hula dashboard thing
in base isolation.
In base isolation.
That's a great vision.
Okay.
Yes, that's exactly what's happening. Is the hips are moving.
Yeah.
Because in this case, the ground moves, therefore the hips are moving.
Yeah.
But the grass skirt kind of goes about it without getting hurt or damaged.
Right.
In this case, the grass skirt happens to be the content.
Yeah. Two things. One, I love how whenever you said the hips, we're going to hopefully have it on camera, you start sashaying.
Yeah, I got to do that.
Like, why not? And two, I could just imagine those contractors installing that base isolation, and when they get to the grass skirt part, they're like, I don't know what's going on here, but but it's on the blueprint. Let's just get it installed.
Well, when you do that, we were fortunate enough to work with a lot of very qualified contractors that know how to install these across the country. And again, it's mainly focused in high seismic regions. And so is that a solution for a project in Nebraska? No, it would be inappropriate. Do we design, would I encourage a client in, let's say, Oklahoma to consider designing for tornadoes? Of course. Do I think base isolation is the right solution to design for tornadoes? Absolutely not. So, again, I like looking at opening up my, if you will, toolkit to say, what's the problem?
Right.
Let's implement the correct solution, and then we can present a variety of solutions to our client, and then help them understand the benefits of each. Because again, one solution is not right. I mean, a lot of people talk about how can we do this faster? How can we build our data centers faster? And it's like, well, some people are looking at modular data centers. Some people are looking at, well, if we always have the same grid and we pre-order the steel, that's always going to work. Yeah, until it doesn't, until there's new technology. So, I can't tell you in the last 5 years how many times we've started a project, we've identified along with the architect and the user, here's the column grid that is most efficient for you, and this works for what you've got. And then you finish the design development drawing, say 6 months later, and all of a sudden technology changed, and the servers got 6 inches, or the cabinets that they're going to use are 6 inches bigger, or they may want more space between their hot aisle and cold aisle, whatever the case may be. And all of a sudden that great modular space that you had, or in this case, predefined column grid with pre-purchased steel, all of a sudden that column is in the way and you're going to lose a server cabinet. So is that a big deal? It's not as big of a deal if you are only on one floor. But if you're doing a 4-story building and you lose, say a dozen cabinets on every floor, that's $12 million per floor times 4 floors is $48 million. That's probably about what you're losing per year. There are better ways to plan ahead. So sometimes my company and I try to encourage, let us think through it, what the problems might be. And one of the first questions is, are you anticipating modifying the technology that you're planning for this facility? Are you anticipating it changing? Or, are you at the end of the technology curve on what you do, or are you at the beginning of the next one? Or do you know?
Right.
Some people can answer it, some people can't. So
Our buddy Craig Pennington came on the show, and I could imagine him here. I don't want to put words in his mouth, but in my imagination, he's like, I don't know.
Right.
I'm guessing.
Right.
I know it's being released from the chip makers. We have a reference design. We've got digital twins over here, but we haven't received it yet. It's not rolled off the assembly line. We know how he's not with Oracle anymore, but that's the idea. And I think he probably represents most of the, certainly hyperscale world, and probably a lot of the Fortune 500 anyway, of how they're trying to, whether I'm a fintech or whatever, I'm trying to, I think my solution is going to run off of a rack with this many GPUs in it, or CPUs for that matter. I think it's going to be cooled like this. I think it's going to have an output like this, whether that's for training or inference or whatever it's doing. Like I imagine, but it's 18 months away. And so when you ask them that question of, is your solution going to change? Are you locked in? Like, who can answer that with a straight face? Unless it's, we're doing spreadsheets. And that's only, we expect a 3 to 5% incremental change in performance requirement or storage requirement or something like that, which is a significant portion. I don't want to say that it's not. But the biggest needle movers are these, whether it's for energy needs or cooling needs or whatever, space. It's for these other things where...
they don't know.
They don't know. And so how do you design for infinity?
It's a great question.
ISO pads.
No. So one of the biggest challenges in a data center is incorporating the appropriate superimposed live load, which is what's the load from the cabinet, what's the load from the servers. And as we know, in the last 3 years, they have been increasing a lot.
Right.
Just like the power demands have been increasing a lot. So you've got weight, you've got heat, you've got electricity, you've got all the gems. So the entire data center is being affected.
Right.
So what we have historically done is we will look at in a colo facility, for example, it's rare that you get dramatic changes from between when you start and when you complete your colo, because the technology for that colo is pretty much driven by how much power is going to go to the cabinet, and that's how the lease is signed.
Okay.
And so
help us to do this real quick.
Sure.
When you say colo, what does that mean to you? Is that a certain size? Is it a certain type of customer? What does colo mean?
So a colo facility, co-location facility, means that there are multiple tenants in a given building.
Okay.
And many of those tenants will take what we call a cage. The cage is, say, 10 server cabinets.
Okay.
So you could have, an accounting firm in one cage, and immediately adjacent to it, you could have an oil company right next to it, and that's all the space that they need. So in a colo environment, it's not like the AI environment where you're going to be incorporating these chips that are changing constantly. It's pretty much it's a 13 kW cabinet and that's what you design for. However, for the hyperscalers, they're the ones that don't don't know. I mean, they do know what's coming. They don't know necessarily how it's going to impact. So what we try to do, and many other engineers do this, we're not unique to that, is we try to say, well, let's put a little bit of juice in your foundation, just in case. Let's maybe put a little bit of excess capacity in your floor. I was talking to Jimmy Bailey just yesterday. He was doing a presentation at AFCOM here in Atlanta. And one of the comments that he made, which was quite perceptive, thank you, was that, as the server cabinets get heavier and more power is necessary, they are tending to move apart. And so we've seen this over the years as the old colos, as an example, had, let's say, 3 kW cabinets that maybe weighed 1,500 pounds. Today, a lot of the server cabinets are 3,000 pounds. So logically, if you designed for a 1,500 pound cabinet before, and now you're replacing it with a 3,000 pound cabinet, you probably can't put as many cabinets on that floor as you could when they were 1,500 pounds. Or you separate those cabinets out further. Again, trying to match the floor load capacity of the building. So, that works for about 3 cycles of change in the servers. And then you get to a point where you go, okay, now I'm going to put in say a 20 kW cabinet or more. Now my load's a lot more. That cabinet's now going to weigh 5,000 pounds. And all of a sudden, that floor that you designed 20 years ago can really no longer carry the same, certainly not the same quantity of cabinets. So what do? Well, we encourage clients to consider using this particular facility for what it was intended for, which is for colo with the lower weights, or spread them out to the point of maximizing the power with the density of the floor. Does that work? Most of the time it works for a while. That's what I was saying. So now what we try to do is anticipate what might change. Is it a 10 to 15% change in weight, let's just say? Chances are good, yeah. That's probably not a bad number to use for maybe 3 cycles or refreshes of the servers. So the hyperscalers embrace that concept. Developers are a little less excited about that because it increases your first costs, and we totally understand that. It's a business. That's what they're trying to make the most, meet their commitment to provide a building, but still make a profit.
Yeah.
So we have to listen to that and work with the client for what they want and what they need, both short term and long term. Obviously, if you're going to have to walk into a building and modify a foundation or modify a floor to support more load, that's excessively costly, and it's nothing but downtime for your data center. So we encourage people to think ahead, even though nobody knows what's happening in 20 years. I don't think that way anymore. I always go, let's just kind of think 10 years out. What do we think might happen? So 10 years ago, we were designing our floors instead of for conventional, say, 175 to 200 PSF, we frequently were encouraging our clients to go 250, go 275 which would represent the load demand from a variety of cabinets on top of the floor. So,
as you're describing that, I'm wondering who else in the construction world's dealing with this. Like, new apartment buildings aren't.
No,
they don't have this crazy, a mall, bridges. We got bridges. Every, 150-year-old bridge or a 100-year-old bridge, sure, or a small hometown, covered wagon bridge, of course. But there are bridges that have, in New York or other great infrastructures, that probably easily have another 100 years of with proper inspection and whatever. I'm not talking about not maintaining them. And I'm thinking about our world and not just this rapid change, but the change with, to say it in IT terms,
Right.
we think, well, 300 pounds per square, is that the right?
Right.
Because when we go to the weight of those racks that you were talking about, let's just say a 20 kW rack, and I want 10 of them. Well, now they're also talking about, well, I'm not going to give you a 208 volt
Right.
branch circuit. In fact, I might even make it DC power, and it might be 415 volts, and it might be 120 amps, and these other things. And so now these cables, well, certainly if they're AC power, they're going to, Godzilla's going to have to lift them in place. But like the weight of the infrastructure to get to the rack, and then what's implied by that much IT in the rack is the heat that you have to mitigate.
Yep.
And so now you've got more weight coming into this dense area to cool it, and the piping.
100%. Right.
Like,
yeah.
who else is dealing with this challenge that we're in front of?
You mean other industries?
Other
like
industries that are building infrastructure like this. I can't think of anybody.
I can't either, really. I mean, like you say, the apartment building, it's roughly the same amount of live load. It's not changed that much. What struck me or what I thought about when you said this was, recently we evaluated a building in San Francisco that was going to store new electric trucks and vans, which are substantially heavier than a conventional car.
Sure.
So we actually had to identify to the prospective tenant that here's how you can space your cars, because unless you want to fix strengthen your floor. And they were kind of scratching their heads like, well, we've been using it as a parking garage. It's like, right, but for passenger vehicles, this, what you want to put in here is 3 times the weight of a passenger vehicle.
right.
So, no, you can't do it. It just, unless you want us to fix it, we're happy to fix it. So,
Right.
there are some outlying things that are being affected, by our technology changing, to electric vehicles, for example. But I have to say, one of the exciting things about being in the data center industry is that change comes quickly. The demand for the production, the design of the building, the production of the building, the construction of the building, that time frame has not increased. It's always, everybody wants to shorten it. And for years, excuse me, we'd start a project and the joke was, you're late. We'd sign a contract and they'd say, yeah, you're late. When are we getting our steel order?
Right.
Fortunately, good or bad, with the different, timelines for delivery of equipment, a lot of the users like yourselves probably in the past or most recently probably pre-bought a lot of equipment, so you have a constant supply,
Right.
as opposed to years ago. It was, well, let's let the electrical engineer and the owner determine what equipment and what topology they want to use, and then order the equipment and order the transformers, and then you used to be able to get them relatively quickly. Then come along, right around COVID, you could no longer get them. And so when you could get all of the equipment relatively quickly, the contractor needed to get the foundation in and get the building up to support the equipment, because in order to start using the data center. When the delay in the supply chain started to occur, we were able to take a bit of a breath and go, okay, now we can think. Those challenges with the supply chain seem to have diminished substantially, mainly because of the way people are procuring the equipment these days. So now we're back to, you're late, and don't make a mistake. So
Right.
as you can imagine, I always tell people, like, if structural engineers make a mistake, either people die or things fall.
Right.
If a mechanical engineer makes a mistake, people aren't comfortable.
Right.
There's a little bit, I'm sure there's a lot more legal
Right.
issues, but boy, I'll tell you, that puts a lot of stress on us. So we like to be accurate all the time. So.
I've worked around enough engineers in my lifetime, IT and otherwise, that it's amusing to me as someone who's played an engineer but is not an engineer at all, to hear the compute guys snickering about the network, or the storage guys. The mechanical guys will snick about the electricians and the infrastructure, whatever. Depending upon which one you are, it's like sharks and jets. They snap their fingers and, if it weren't for us, you guys would all be, you wouldn't have a thing, you wouldn't have a roof, you wouldn't have walls, you wouldn't, I just make notes when I hear a particularly good zinger and try to save it for later use. So when we were talking about the complexity of buildings, I'm imagining your example of electric vehicles. And so for sure, the weight, people are always surprised by the weight. But also the need for life safety if there's a fire in that vehicle and it's parked, right? Because, very few fire stations there are very few abundant fire stations that can go in quickly with a trained team and put out a fire like that. And then they're working through it, of course. Right. So those are complex, but the size of the entryway is going to be about the same. How you navigate from, the street to your parking spot, how you manipulate a vehicle, maybe even some point, like you get out if they're autonomous and the vehicle just parks itself, like it's communicating with the local intel in AI within the building, and it just self-parks or elevator or whatever. Like, that's really cool technology. But the envelope of it, anyway, feels like it could, in the whole of it, not that much of a change. When you think about a data center right now, at least these the ones that are trying to accommodate all these different complex solutions. And I am guilty as anybody in saying, like, an AI data center. We just build data centers here. Right. Whatever is going to be used inside it, we just build data centers. That's what we do. And so whether it's used for training today or some combination, or it's multi-tenant, what you would call colo, or it's a single tenant, or just a few tenants, whatever that looks like, it's got to be able to last a while. We want our data centers to last hundreds of years if possible. But it feels like so many things we're looking at that you have to be able to accommodate when you're in this infinite, like, what's the energy source? Is it from a grid a ways, or is it on site? What's the cooling infrastructure? Are we going to make them more and more and more where the compute, the storage, and the network are so resilient that, you can run them really hot and they don't need as much, whether that's air or liquid or whatever, all of these different things. How wide are the racks? For the longest time, these racks and these spaces, like, one of our early claims to fame was we really perfected, and I think we still do it better than anybody, the logistics on how we receive infrastructure into a data center. Like, this is our, it's not secret, but it's like these little nuances. We make it easy to receive something, get it to its spot, get those electrons working, and then the human beings that interact with it. It's a restroom nearby, or there are multiple freight elevators so people can get up and down because it's a fully operational Death Star. Like, all kinds of environments are coming and going from multiple people, even if it's a single customer. And so the degree of things that are changing in that space, it feels like, not an expert in other infrastructure, that it's a lot more complex for a facility that doesn't. People keep telling me it's not that complex to accommodate, where we are today. We want to get over there to paradise, and we got to eat on the way to paradise. So how do we do these things? And I'm just curious, if you had been bumping into this in any other type of infrastructure, either yourselves or your frenemies that you talk to in their structural engineer challenges. Yeah.
Honestly, the changes because of the hyperscalers and AI and those demands are, from my experience, are quite germane just to this industry. So are they impacting other industries? Not nearly as much. So, sometimes, years ago, right, actually during COVID, when Amazon came out and they had, the immediate deliveries, warehouses that were just big stinking warehouses that, had lots of vertical racks. That was the model pre-COVID, meaning, you'd call Amazon or whoever, and a week later something would show up. Well, then that changed to a lot more immediate delivery. So you have the distribution facility, and then you have the last mile building. And so these last mile buildings that were warehouses distributed around any large municipal area or even not so large municipal area, they had to accept the product from the large warehouse, and then we ended up putting nothing but conveyors all over these buildings, and it's amazing to watch. If you've ever walked in one, it's really quite amazing to watch. But my point is that because of the desire of people and the, if you will, forward thinking of companies like Amazon, FedEx, UPS, to create a more efficient conveying and delivery system, that was a big change in the industry, I thought. So we saw, a big change there. At the same time, we were seeing dramatic changes, mainly because of the amount of use during COVID, as an example, of Teams and WebEx and all of the different users. And I mean, that dramatically increased. So that changed a lot. In the life sciences industry, that is a little bit more, if you will, stable. What we see is there's more, a lot more R&D than there was pre-COVID or back in 2008, 2009. Now there's a lot more R&D. Currently, there's a bit of a slowdown in the life sciences industry, but it'll come back. And so what we're seeing is changes to the buildings. So we've taken buildings that are office buildings and converted them to life science facilities, R&D facilities, where we have to put in some extra cooling, some extra filtration, maybe strengthen the floor a little bit, because typically in a lab you have greater loads. So they go through a life cycle also, but it's in our experience, it's not as fast as what we're seeing today. I mean, it's what we're seeing today is, everybody's kind of scratching their heads like it's just going to keep going. It's like, well, it might, like Craig had said, well, I don't know what's going to happen in 10 years. Neither do we. So that's why we try to kind of agree on what makes sense to the people that we're working for. Because far be it from me to tell somebody you should do this. It's like, well, no. If I understand what your parameters are and what's most important to you, if it's first cost, then that's what we'll do. If it's longevity of the building, okay, well, let's consider maybe making the building a little more robust. If it's, I want to make it carbon-free, okay, well, let's focus on that and how are we going to do that. So there's a lot of different parameters. None are changing that I see faster than what's happening in our industry.
Hey, one of the things you said before, I love to get your take on this. Let's talk about supply chain for a second.
Sure.
Where do you think we're at in our industry with supply chain? As you're advising people, like, is it robust? At least from the envelope of the infrastructure. Maybe we could talk about the gear separately that's going into it. But what's your take on it? Where are we at?
Great question. So years back, clients...
How many years back? 10, 20,
let's
6?
Let's say 10 years ago.
10 years ago, okay.
Clients wanted to take everything off the roof and put it on the ground.
Oh, yeah.
It's like...
Hated it. No perforations.
Right. We don't want anything on the roof. It's like, okay. That has its challenges. So you have to then have a yard. And generally, as power demands came up, even back then, you had to have, your stacked units out in the yard. So all of a sudden you have infrastructure in the yard that you didn't really need to have. So, over the years, the above roof platform has become quite common.
Why is that, do you think?
Well, real estate and ease of, where you have a roof that's doing nothing for you.
Right.
So if you can put an above roof platform up there and put all your air-cooled chillers, TES tanks, whatever you need to up there, you have something to work from. And, there's been years where clients would say, well, we want to get rid of that platform because it's way too expensive. It's like, yeah, but then you're going to have 8,000 penetrations through your roof membrane, and that's not a good idea. And some people grasp that, and some people say, well, we want to do it anyway. And it's like, okay, it's your building, do what you want. But historically, putting an above roof platform gives you the most latitude. That's kind of what I try to tell clients is that, look, if you don't really know the size of your chiller, if you don't really know whether you're going to do a combination of water-cooled and air-cooled, if you don't know what that combination looks like, put the above roof platform in, or at least design your building for that. We can come back. We don't have to necessarily. They don't have to put the above roof platform in while they're building the building. It is the easiest. It is the most efficient. Therefore, costs the least. But a lot of times, what we'll do is we'll build the superstructure, extend, columns up through the roof to accept a future platform, and then that future platform can be deployed over time. And sometimes that platform changes over time. So what might be called phase one, which is the first, let's say the third or a quarter of that platform, it might use only air-cooled technology. And as the industry has matured, phase two comes along, and somebody says, you know what, I think we should incorporate a little bit of water-cooled. No problem. We can do that with our platform. We've accounted for that. And so, a lot of times what happens is, again, it becomes forward thinking as a team, not just for the structural, but talking to the owner, talking to the mechanical engineer, like, well, if you're not anticipating, 24-inch chilled water pipes going around the perimeter of your above roof platform because you're solely an air-cooled chiller system, maybe we should. Let's just throw some extra load in there. So what over the years, we've been very happy that our above roof platforms, you can kind of put anything you want on them within reason. So it again gives flexibility to the owner to be able to change without a lot of cost. And again, this is not germane to Paradigm. A lot of the structural engineers that are quality structural engineers that know how to do data centers are thinking that way, and it's good for the whole ecosystem, quite frankly, because then when we look at somebody else's work, we can go, oh yeah, they thought about that. Good for them, and there aren't as many surprises as there used to be.
How's that impact the supply chain?
So it allows the owner not to necessarily have to pre-order or, if you will, warehouse the equipment ahead of time. They can say, okay, I'm going to do phase one. Let's make sure we get that ordered right away. So we design our roof platform for whatever equipment that they've been able to identify for phase one. For phase two, maybe that's a year later, let's just say. Because we are deploying the platform in phases, they can order their equipment whenever they want, and then we can modify that platform. If, as an example, it's going to be 3 years and they have to order all of their air-cooled chillers day one, it's like, okay, if that's what you want, we can design the platform for that. But between when they set the order and when it's coming online, there's going to be a change. And so you kind of have to have some reasonable flexibility in your design, and you should. So
It feels like, because of this uncertainty, and I'm genuinely curious to get your opinion, whether it's the roof infrastructure that you were just describing or other elements that might be in the yard or some of the components that we're not experts in, but we're in this business. And so we hear people talking about the electrical or mechanical infrastructure that comes inside a facility so that you can develop the whole platform, right? That somebody can then come and deploy their infrastructure in that does their business, provides their 911 service or their e-commerce or whatever it is. It feels like over these last few years, like we're still in this mode of, yeah, I'm probably not buying infrastructure for 5 years down the road, but I am for sure going to buy it to get me 18 to 24 months down the road so that whatever I've just agreed to in some contractual relationship with somebody, I have a greater degree of control than, trust me, it's going to roll off the assembly line here in 36 months. I want more control over that. Even if I inherit the patching of it, the storing of it, the cycling of it, whatever that it is, so that I can deploy it, because I don't know when the next disruption is. Like, when are they going to get the call and they go clean the shelves of water or toilet paper or Vienna sausage? So to me, outside looking in, it feels like it's still there to a large degree. Do you think that's accurate, or is that, no, we've really moved past that?
Well, since we're focused on the structure, the superstructure, as I mentioned, we've seen clients deploy, and I'm using the above roof platform just simply as an example.
Right.
We've seen clients deploy it in phases. We've seen other clients say just build it all at the same time because, again, it's less expensive ultimately.
Yeah.
And by the time, as that gets built out, and by the time they start placing the rooftop equipment, the balance of the equipment will have shown up to the site or in the warehouse or whatever. So a lot of times again, I go back historically, a lot of people would design an above roof platform simply to take the known loads that are going to be there plus some service loads. And I was always like, well, if you do that, you don't have any flexibility and you can't make a change. And so how about we, again, juice it a little bit to allow for, we didn't know 10 years ago, if you said, I'm going to put a TES tank on the roof, I'd say, what is that?
What is that?
Oh, that's for liquid cooling. It's the thermal expansion tank. So, but I didn't know what it was, and I'm like, why would you need that? So it locally, it's quite heavy. If you have 100 of them on your rooftop platform, that's a lot. We typically are not seeing that. If you're going to have that many tanks, you're going to have vertical tanks that are on a pad out in the yard. These other tanks, usually the thermal expansion tank is utilized for liquid cooling in combination with your air-cooled chiller that you have on the roof to do some to cool the whole data center. So anyway, kind of what I'm getting at is that you can refine the design for something to meet exactly what you know is in inventory or is going to be placed, and there's nothing wrong with that. Or you can say, well, what you ordered may change. I mean, manufacturers change equipment. They say, here's a cut sheet, and by the time you get it in the field, it's like, well, wait a minute, that's 6 inches longer.
Right.
And I feel sorry for contractors because they're like, well, because all over our drawings, we always say contractor to verify, and it's like they would prefer have a beam waiting, so they just put the unit down on the beam. And sometimes it's like, well, if we define where that beam is without having measured the piece of equipment, because what you got as a cut sheet 9 months ago is different from what was delivered, and it's not intentional, it just happens. And so we always like to make sure that we, it's like put in as the least amount you have to, because it could change. That, again, that depends upon what type of limitation there is in the supply chain. And that this goes the same for a transformer. Most people, like QTS probably says, hey, we want a liquid cooled transformer. That's all we ever use. Okay, got it. Understand how we're going to plan for that. Other clients go, well, we're not sure that's the one we want. Okay. Usually the electrical engineer is working with the owner trying to decide what product they really want. And a lot of times, buildings are done in phases. There's usually the core and shell and the tenant improvement. And frequently the core and shell is done far in advance of has to be done so that when you're doing the TI, you have a building there. So you're doing the building. Yep.
We love our acronyms. What is a TI?
Tenant improvement.
Got it.
So, the owner can say, I'm going to put truly, we used to call it stacked generators, which is there are manufacturers out there that will literally stack a generator on top of it itself, on top of another one. What we always try to say is, well, that's okay, but if the tenant that's going to take the space, they usually pay for those generators, or often do, or will request a specific generator type. We always recommend going with what we call a racked generator. That gives you the flexibility to put an independent generator. In other words, you put one generator in that's on grade, and you put another generator above it that is on a platform, a steel platform, that can accept that generator. And that way you have the maximum flexibility. Is it more expensive? It can be, but it gives you the maximum flexibility. So any tenant that comes in, they can deploy whatever solution they want in that equipment yard. So.
It's I'm still watching. I'm not convinced that. I think there's a real opportunity or a philosophy for if you're able to manage your inventory, which is basically what I'm talking about.
Yep.
So if I buy a supply chain inventory, and going back to my Lego analogy, so let's say I'm putting Legos on the roof for my whatever my cooling solution is, it's starting on the roof. And I don't want to strain capital, so I'm not going to, if it's a 500,000 square foot roof, I might just do the first quarter of it, whatever. But I still have the other 75% somewhere in my control because I've got a bunch of roofs that are in various forms of development. And, worst case scenario, if what I imagine the rest of the roof population doesn't come to fruition at some improvement or some change, this other stuff's not going to be stranded because I'm going to deploy it to a different roof in the meantime. Something comes online. We take advantage of an opportunity that we weren't expecting. I'll just go put those Legos to work over there while I get the new Legos in and then deploy that across the next half or whatever. It's this weird paradigm where you want both flexibility and standardization.
Yep.
That's why we're so enamored by digital twin tools, things like that.
Sure.
Because I can play with them, not just hypothetically, but in as close as you can simulate digitally as possible, both the integration, the performance, inventory, like all of these things, loads, both on the infrastructure and then how it does its job to whatever it is I'm trying to get it to cool or move electrons for or packets or whatever. But it is my personal experience so far has been there is still this propensity for I'm going to go to the store, I'm going to get all the paper towels off of it, I'm going to go put it here because I got 6 homes I'm supporting or whatever, and I know I'm never going to not need paper towels or other things that should I not? Because it's summertime in the Midwest,
right?
And there's a tornado every 7 days, which to me would be move. Like I don't know, if you guys kept having earthquakes and fires every 40 years, like you did 150 years ago, it's time to go, baby. Yeah. Nature's trying to tell us something. We probably shouldn't stay here. Yeah. But I'm curious, what's just your spidey sense telling you about where we're at with the supply chain world right now?
So my belief is that the supply chain has improved quite a bit.
Okay.
That's what I've heard. That's what
Like the process or just inventory?
inventory.
Okay.
Inventory, and I think a combination of a lot of things. If you have one product that you only want, and let's say that one product is manufactured in South Korea, and there's a disruption in the shipping, let's just say, or air freight because you can't send it by air, you've got a problem. So, but if you can, as you say, if there are 4 suppliers that access or manufacture in 4 different regions, you diversify, you have flexibility. You reduce your risk. The same is exactly true in what we actually design. When we're designing steel or concrete, it's like, well, you diversify risk because there are those times where, you can't get to a product. Years ago, steel was, impossible to get. And I can remember we were hired to do a building in Secaucus. And the client said, well, here's what we want, but we don't know anything about our electrical room. But here's the outline of the electrical room. First question I asked was, do you want columns in your electrical room? And the answer came back with a resounding no. I'm like, okay. So here's a solution. So we pre-ordered some very large steel sections from Luxembourg. And, the contractor's looking at me like I'm smoking something, and I'm like, well, if in order to meet your long-term schedule, this is about the only solution. We can take a risk and we can put a column in a logical location, but your electrical engineer isn't there yet and doesn't sound like they're going to be there for quite a while. Make a long story short, so we ordered these beams. These beams come to the shop. The contractor, the day he installed them, he came out and he was really proud to see them because they're like 60 feet long. And he's like, I've never put up beams this big. And I go, yeah, it's pretty cool, isn't it? And the benefit was the electrical engineer had a clean palette to work with. So whatever equipment that they and the owner were going to select, they didn't have to worry about obstructions from the structural guy. So a lot of times, we always tell electrical engineers, mechanical engineers, owners, show us what you want and we'll figure out the column grid. Because your equipment is harder to change, and you may not know it. You may there's always these requirements. You need 3 feet in front of a piece of electrical equipment, for servicing and all that. A lot of times the electrical engineer doesn't even know how big that piece of equipment is going to be. They just know the power for it. And so frequently the subcontractor that's going to be on the job can define, here's how big that piece of equipment is, and here's how much space you need. So all of a sudden something that had 3'1" in front of it, so it was, no problem, now is 2'10", and now it doesn't work or it doesn't meet code, and therefore there's a problem. So, the supply chain can be worked around if it's bad. Right now, like I said, I think it's, from what I hear going to these conferences, it has improved significantly. I think also, bringing things back to the United States to manufacture is a good idea. I'm not talking any politics, just like it's nice to think of, hey, we can manufacture not everything, but some things we can manufacture. One of those 4, how about we manufacture it here? Yeah. Is it more expensive? Maybe, but it might reduce the risk. It's the same thing with chips. For a while during COVID and a little bit post-COVID, chips were a big concern because they were all being manufactured overseas. Well, a lot of them are still being manufactured overseas. However, the construction that's going on right now with down in Phoenix with the chip suppliers and the new ones that are coming by Intel up in, I think it's Ohio, they're looking forward to saying, okay, we're going to bring that back here. Yes, maybe it's more expensive, but we're not going to be susceptible to these influxes of unknowns.
Right.
They're trying to. The way I look at it is, in the big picture of life, they're trying to reduce risk.
Right.
Great idea.
Yeah.
Well, we do it in our business. So if you think about it, with employees, as an example, if you only have enough employees to get the work done that is in front of you that you know about.
Yeah.
Okay, you're reducing your flexibility and your adaptability should another opportunity come up. So you're limiting yourself. So what do? Well, you have maybe 1 or 2 employees that are coming up the learning curve, or maybe you have a dozen like we do. You keep bringing those new people in to educate them. Maybe they're not 100% effective today, but they will be because our demand is going to keep growing in our opinion.
Yeah.
So.
When I asked you before, when we were talking about putting this together, I
Yeah.
asked you, hey, what do you think the most important thing to talk about is? I'm always curious.
Sure.
Yours was so spectacularly wrong, I started laughing. I'm just teasing. As it happens, it aligns with my personal and our corporate one. But how did you answer that question?
So when you asked me, I kind of snickered and said, well, my employees are the most important thing.
Yeah.
And, a lot of people may disagree with that, but here's my thought process. Is the term paradigm, as an example. I use the definition of an excellent example, kind of the way to do things. And I have focused, since I opened the business, as focused on my employees, make sure they're taken care of, make sure they're paid as well as they can be, as well as we can afford to pay them. Hopefully there's, 1 or 2 events throughout the year that we can celebrate, either be it a holiday event or a summer event. Give them if you will, a path to success. And so my main focus has always been, look after my employees. Not necessarily what I had, because a lot of my previous employers didn't necessarily look after their employees that much, or I didn't feel that way. But I focus in on that. So, we make sure that there's opportunities for a week's stay, somewhere in the mountains, so that employees don't have to reach into their pocket to go take a week off. They can just go up to the condo in Tahoe and it's all theirs. So kind of focus on that. And then, like I said, also, I'm a little older than you are, David. So, another 10 years.
Just a little bit.
Another 10 years, I'll probably be, winding my events down, or my participation. So I have to make sure that I, provide a path for my employees to have a successful company as I walk out. And so that's what I'm doing. And that path is twofold. Number one, it ensures that the company will be successful long term, which is beneficial to me. But at the same time, it's also ensuring that my employees don't say, wow, I could go out and start a different company because he's not doing it right. It's like, no, I want to make sure I do it, if you will, the saying, be right by them. Make sure you do it the good thing. And I feel pretty good about that. We've got great retention. I make it a point to go to all of my offices all the time. We actually rotate our senior staff between all 3 of our offices for the sole purpose to create an environment that is one. And it kind of sounds like, QTS does something similar. You were just talking about it earlier today. And, it really does help because, you get on these Teams meetings, and if you've never met a person in person, they're just a talking head to you. They don't, there's no emotion. And without that emotion, you don't really necessarily didn't really build trust, safety. We're structural engineers. We're kind of not known for empathy, not known for, being sensitive, but it is important to me to make sure that, we know the names of people, that we know what's going on with their families. Maybe one of their kids is sick. It's like, that's too bad. I mean, so, hey, I focus on my employees. So, because really without the employees, we can't do any work. And so then to kind of go ahead with the next answer to the question you haven't asked yet is, the next thing is the client. I used to work for a firm where one of the owners, he really detested the fact that I would help a contractor understand something. And I was like, I don't don't see why you don't like that. And my way of helping a contractor is jump in the ditch, help them lay out some reinforcing steel for footing, or thread. I was known as the Lenton coupler guy. So Lenton couplers are elements that are welded to typically a face of a steel column, and then you thread a piece of rebar and screw that piece of rebar into the Lenton coupler. And it's so you can make a physical attachment from two pieces of two different elements, a column and a piece of rebar. So in this case, it was to create a fixed condition at the base of a column. Anyway, make a long story short, the laborer that was working on it was sweating like crazy, didn't really understand how to do it, and it was a sequence issue. And so I hopped in the ditch with him, took off my jacket, hopped in the ditch with him, and said, "Here's how I would do it," and showed him how to do it. And he's like, "Wow, I've been in a lot of ditches, and I never had a structural engineer jump in here."
Right.
I got out of the ditch, and of course I got pardon the expression, an ass chewing from my old boss. That's when I decided, no, I'm gonna. This is who I am.
Right.
This is who I want my company to be. I want us to always be helping people understand, be it from a super technical side on base isolation, talking about all the theory behind it, talking about inelastic behavior of buildings, talking about doing a pushover analysis. What's the beauty of it? How is that good or bad? Taking all those technical things and bringing it to a level that that your audience understands, whether that audience is an equivalent PhD person or a guy working in a ditch. And we work really hard at trying to make sure that everybody understands what we're doing and why. And sometimes, it can be frustrating because we're not the best teachers sometimes. We don't necessarily know what our student, our client, may or may not understand. So it's work, but it is quite rewarding. One of the things, in fact, we bring up Craig Pennington. I've known Craig ever since he worked at PSINet. And that was one of our first data centers back in probably 1999.
He's that old?
He's older.
I'm teasing.
Yeah. But
He would send me a nasty gram.
But we were working for him, and the solution I had was, look, I knew what they wanted to do, and I said, the fastest way to get this done, drop all your footings by 8 feet, and then you can get all your conduits in, and you won't have any issues, and we can get on with the structural steel of the building, and you don't worry about it. An electrical subcontractor will come in right after. And he was just enamored with that solution. And even Peter Gross, we were working on a project up in Seattle, and he and Nick Yalick used to work at EYP, and they basically called me immediately and said, "Hey, you remember what you did for Pennington down at PSI?" I go, "Uh-huh." They go, "That's what we want you to do up here." And I'm like, "Okay." And it was, the idea was I explained why I was doing it. And once I explained why, immediately the designers could go, "We understand that. Oh, this helps us." It's like, "Oh, good. I'm glad it helped."
Right.
Yes, it costs more, in construction dollars, but no.
Yeah. I invited you to come or asked you to consider coming on the podcast because I've heard you speak before, and it wasn't how fascinating steel and timber infrastructure is. It is, in addition to your expertise and time, it's this. It's this. I've seen you live out sort of this embodiment of your people over a period of several years anyway. I've heard the side conversations. I've been around, and I'm like, I dig that kind of a human being. Even if we disagree on the technical solution to a business problem, right? And so, how from your seat, as you're either helping operators like us who design, build, operate, and maintain data centers for mutual clients, and we put them in communities. Or just as you have a conversation at the grocery store, on an outing or whatever with people who ask you, what do you do? And you say, well, I help build infrastructure like this. that supports these things. And they're like, well, what is that? That doesn't seem like great. How do you have that? It's a long preamble, but I'm very passionate about this. How, one, am I assessing this correctly? And two, how does your organization help to engage, or wherever, however you work with, to engage communities in a practical way to help work through misinformation, both to the community, but also to come back to your customers and say, hey, this is what people are thinking. These are the conversations I had, but we need to get better at having a real conversation and making ourselves available. Back to that long-term relationship that I was talking about before. Like, I want a data center to be thought of like anything a community would embrace, a school, a fire department, or whatever. We need this because it helps us in these meaningful ways, not as they're just, they're clearing out space to put it. Nobody says that about a fire department. They got to find the right spot.
Right.
But they want it there to save lives. And when it's not actively saving lives, they want them to go teach kids in the school and to be part of the scout program or whatever else they do. So as you react to that, how is it that you imagine community engagement?
That's a great question. So, as structural people, I can't say that we are connected to the community overly. So we are maybe kind of the back door. So most of our community involvement and enrichment, if you will, comes through the building department, oddly enough. So historically, engineers, designers have to have their designs reviewed by a building official. And frequently there's a disagreement between the building official and the designer. And frequently the designer feels they're right and the building official feels they're right.
What would be something they would disagree on?
Whether or not a 5% overload on a steel member is acceptable or not acceptable. Okay. Not a big deal.
Right.
I try to always take the side of the building official and go, well, look at it. People are, pushing things down their throat every day. And, oh, this is fine. You're being ridiculous. It's like, well, how about we work a little bit differently? Let's work together collectively. And you can't always do this. There are some, they're just,
it's unreasonable.
Yeah, some engineers are unreasonable and some officials are unreasonable. So, like when we start a project, what I try to do is always go meet the building official. I try to go talk to them and say, here's what structurally, here's what we're going to do. Got any questions about that? Especially if we're doing, more sophisticated projects, base isolation, fluid viscous dampers, performance-based design, anything like that that's out of the ordinary. I always try to go to that building official and talk about why this is beneficial and give them if you will, an outline of here's what we're going to show you. Kind of give them, here's a table of contents of what we're going to supply, and we're going to bring you along the learning curve all the way along and bring anybody you want to learn. Because we're gonna do this because this is the way we like to progress. We feel it's valuable. I can't tell you the amount of times that building officials have kind of stopped for a moment and said, we really appreciate you treating us like humans. It's like, well, no problem. What it does is it builds trust, and again, it's back to that same community. And so we find that those sometimes, if there's an opportunity that the building official says, could you come and speak to our meeting? I know that's not what you do, Mr. Lindorfer, but please come because we want you to tell at this meeting. We want you to explain to the community structurally what's going on. It's like, sure, no problem. I can't say it happens all the time, but it has happened. And I'm delighted. It's like, sure, I'd love to do that, to describe, not necessarily what you guys do, because you guys are the experts at that. But from a building standpoint, I can tell you what we can do. And, whether that's a new technology, base isolation, whether it's a conventional building, whether it's a building that we're going to put underground and we're going to, cover over it. It's like, I'm happy to describe any of it. But again, all of this, to me, it all comes back to the more you get people to understand what we as an industry do and if you will, demystify it a little bit. The average person doesn't know what goes on in a data center. Mm-hmm. They don't even know that there are server cabinets in there. Mm-hmm. They have no idea. Mm-hmm. They just know that, there's a big box and I don't like it.
Right.
So the more you can demystify that, walk into in my opinion, walk into the local butcher shop and start talking about, hey, this is what we do. And, that big ugly building that you don't like, here's why. Here's what goes on in there. You can educate people. Where I live in Marin, quite frankly, my wife always teases me. She goes, the butchers love you because you ask them their names. You're truly engaged, even though you don't see them that often. Mm-hmm. But she goes, when you walk in the door, they're always like, okay, they're ready for a conversation. And it's like, I like that because, again, it's a sense of community. It's like what you were saying about that couple that moved to Idaho. It's like, yeah, the living's great, but if you don't feel a sense of community, do you really want to be here? So, that process of engaging with the community, I find to be quite rewarding. Mm-hmm. It doesn't happen that often. Mm-hmm. That's why, like I do a lot of these both events, either speaking events or attend these different events about in the data center industry or in life sciences. Most of the time, I'm not on stage talking. I'm a moderator. I try to get other people to talk because nobody wants to listen to a structural engineer. It's boring, quite frankly.
I'm glad you said that at the end of this 2-hour conversation.
But, the beauty is that I learn a lot from doing that. Mm-hmm. I can go to the community involvement at these events and talk to the mayor or talk to the community development person about what we do and offer, hey, if you ever need any help, let us know. Mm-hmm. We're happy to, like this, you said, hey, would you come? I was like, I'd love to. Mm-hmm. Would I have reached out to you and said, hey, David, I understand you do a podcast. I'd really love to be on it. Mm-hmm. I probably wouldn't have done that, Maybe I will again. I don't know. Yeah.
Well, not after this.
I'm cut off. I know.
Well, Kurt,
this has been a lot of fun.
A lot.
Yep.
Thank you so much for coming on today.
Thanks
I
for
really
the opportunity.
appreciated it. Yeah. And hey, look, if you enjoyed that conversation, hit the like button. And if you loved it, hit the subscribe button. We'll see you next time, everybody. Have a good one.